Hi, this is the Science Chef. This is another edition of my 2023 JAMB Preparations series. In this video, we'll be solving more questions on acid, bases, and salts, and particularly, we'll be solving questions on the year 2021 UTME examination. I'll be looking at questions on indicators, preparation of salts, water crystallization, solubility of salts, and hydrolysis of salts. If you'd like to watch our previous videos on this series, kindly check the links in the description. So let's start. Question 1. The color of phenolphthalein in an alkaline solution is? Yes, we treated this partly in our last tutorial, so check the link in the description. We won't waste much time on this. We gave you a list of indicators and their colors in the different media. So the color of phenolphthalein in an alkaline medium is pink. That's option C. Question 2. The color of litmus in a neutral medium is? Like I said, we have dealt extensively with indicators in our last tutorial. So if you'd like to learn more about indicators and pH, check our last video on acid, bases, and salts for 2022. And also you can also watch our video on pH and indicators. The link is in the description. The answer to this question is purple. The color of litmus in a neutral medium is purple. That's option D. Question 3. Insoluble salt can be prepared by A. Titrating an alkali against an appropriate acid. B. Reacting an acid with trialdehyde 4 salt. C. Direct combination of the elements which make up the salt. And D. Mixing two soluble compounds containing the metallic radical and the acidic radical. Right, this question is on preparation of salt and basically on preparation of insoluble salt, right? The preparation of salt is based on two properties. One, the solubility of the salt, and two, the method of recovering the salt, right? Now, based on the solubility of the salt, you have method for preparing soluble salts and method for preparing insoluble salt. The three major chemical properties of acids are the methods used for preparing soluble salt, which is what are listed in these options here. Titrating an alkali against an appropriate acid, that's neutralization. That's reaction between an acid and a base to form salt and water. Reacting an acid with a trialdehyde 4 salt, yes, that's also possible. That is reaction of acid with trialdehyde 4 to form salt, water, and liberate CO2. That's a property of an acid. Then there's another chemical property of an acid that is not here. That's reaction of dilute acid with an active metal. That will also form a soluble salt. But this direct combination of the elements which make up the salt is two ways. It can either be used for soluble salt or for making insoluble salt, depending on the type of salt that you want to prepare. Now, the method that is specifically used for preparing insoluble salt is the method of double decomposition. That's mixing two soluble compounds containing the metallic radical and the acidic radical of the salt. Example, if you want to prepare silver chloride, we will look for a soluble compound that contains the silver chloride, that's the Ag+, and another soluble compound that contains the chloride radical, that's the Cl-. So in this case, we can use something like AgNO3, which is soluble. Remember, all trialdehyde salts are soluble, and combine it with NaCl. All sodium salts are also soluble. So by the time these two react, there will be an exchange of radicals. So this and this will combine to give us AgCl, solid precipitate, while this and this will combine to give us NaNO3 aqueous. So that's why the answer to this question is D. If you want to learn more about preparation of salts, that's soluble and insoluble salts, kindly watch our videos on the preparation of salts. The link is in the description. So the answer to this question is D. Mixing two soluble compounds containing the metallic radical and the acidic radical. Question 4. This is also on preparation of salt. Consider the diagram below. You have a titration setup here. Dilute acid being run into a conical flask containing sodium hydroxide solution, right? This setup is used for the preparation of a salt by, this is straightforward. This is a neutralization reaction. Reaction between an acid and and a base or an alkali. So it's neutralization. It's used for preparing a soluble salt. It is not double decomposition, because double decomposition is used for the preparation of insoluble salts. And it has to do with the reaction of two soluble substances, right, coming together to form an insoluble product and a soluble product. But in this case, in case of neutralization, one of the products is water and the other is a soluble what? Salt, right? Crystallization is used for recovering the salt from the solution. Then direct combination is combining two different elements to form a given salt. So the answer is what? C, neutralization. Water in crystalline salts provides. Now, this question is on water of crystallization, and water of crystallization is the number of molecules of water that is bonded to a molecule of a compound, right? Example, you have CuSO4.5H2O. I also have what? Na2CO3.10H2O. These are salts that contain water of what? Crystallization. Are we together? Now, this one contains 5 molecules of water of crystallization. This one contains 10 molecules of water of crystallization. And the presence of this water of crystallization confers a form of what? Shape and color on the salts or on the substances, right? Now, why is that so? This copper 2 tetrasulfate 6 pentahydrate, if heated and it loses the water of crystallization, it will become anhydrous CuSO4, right? It will become anhydrous CuSO4, and of course losing the water of what? 5 molecules of water of crystallization. Now this anhydrous CuSO4 is white in color as against this that is what? Blue, against the hydrated that is blue, and also it is amorphous in shape, that is, it lacks a crystalline what? Shape, whereas this hydrated one is what? Crystalline in what? Nature. So which means that the water of crystallization confers a kind of what? Color and shape on the hydrated what? Salt, right? Then for sodium triacylcarbonate 4 decahydrate, when heated and the water of crystallization is gone, you now have Na2CO3, which is what? Amorphous, which looks like a powder. That's powdery, in powdery form, compared to what? The crystals of this hydrated salt, right? And of course this will also lose its 10 water of what? Crystallization. So the answer to this question is that the water in crystalline salt provides shape and what? Color, which is option B, color and shape. Question 6. Tartaric acid is used industrially to. Now, tartaric acid, what is tartaric acid? Tartaric acid is also known as 2,3-dihydroxy butane 1,4-dioic acid. It's a very important chemical in the chemical what? Industry, right? It is actually used for making baking powder. Removal of rust. The acid used for removing rust is what? HCl, hydrochloric what? Acid. That's commonly used for removing rust, or what we call what? Pickling of what? Metals. It's also used for pickling of metals. That is before a metal is electroplated, right? You clean the surface of the metal with the acid to remove any form of oxide that has been formed on the layer of that metal, so that when it is being electroplated with another metal or is being coated with another metal, the coating would adhere strongly and it will last and be what? Durable, right? Then to make fruit juice, the acid commonly used here is what? The citric what? Acid. The citric acid from your oranges, from your grapes, your lemons are used for making fruit juices. Then of course to dry substances. Drying of substances, the acid commonly used for drying of substances is what? Concentrated H2SO4, that is concentrated tetrasulfate 6 acid. So tartaric acid is always used for making baking powder. Take note of that. Then another use for concentrated H2SO4 would be as electrolyte in what? In car batteries. Electrolyte in car batteries. H2SO4 is also used as an electrolyte in car batteries. A mixture of HCl and HNO3 is called what? Aqua regia. Aqua regia is used for dissolving gold and platinum. Take note of that. Used for dissolving gold and platinum. While HNO3 itself is used as a rocket fuel. Okay, so these are some of the uses of what? Acids. So these are what I need to take note of. So tartaric acid is used industrially to make baking powder, which is option C. Question 7. Which of the following is suitable for producing insoluble salt? We've already mentioned this. I already mentioned when I was treating, I think, question 3 or thereabout. And we said that the methods for preparing insoluble salt is called double decomposition. So I won't waste time on this. Neutralization is used for preparing soluble salts. Oxidation and thermal decomposition are not methods of preparing salts. You'll need to watch that video on the preparation of what? Salt. A video on the preparation of salt to learn more about this, or to have a full understanding of this concept. So the answer is what? Option D. Question 8. Which of the following salts is slightly soluble in water? This is about solubility of what? Salt. Soluble and insoluble what? Salt. There is a concept for identifying soluble and insoluble what? Salt, right? Which is also part of our tutorial on preparation of what? Salt, soluble and insoluble salt. Fine, but I'll just give you a few tips. So soluble and insoluble. 1. All sodium, potassium, ammonium salt, or all group 1 salt are soluble. They are all what? Soluble. They don't have any insoluble salt. Then 2. All triazonitrate 5 salts are what? Soluble. All of them are soluble. Then 3. All chlorides are what? Soluble. All chlorides are soluble except what? Except silver chloride, lead 2 chloride, and mercury 1 chloride. And when we say they are insoluble, we mean that they are not even partially soluble. They are completely what? Insoluble. Though there is no substance that is 100% insoluble in water, it must still have a little amount of what? Solubility. But at this level, we can assume that they are what? Completely soluble, right? 4. All tetraoxosulfate 6 are soluble except barium tetraoxosulfate 6, which is insoluble, lead 2 tetraoxosulfate 6, which is insoluble. Then calcium tetraoxosulfate 6 is sparingly what? Sparingly soluble. That is not completely insoluble. That is completely what? Soluble. So it's just in between. Fine. And the 5th one I would like to add here is that all trioxocarbonate 4 salts are what? Insoluble except of course sodium, potassium, and ammonium trioxocarbonate 4. Every other trioxocarbonate 4 is what? Insoluble except the trioxocarbonate 4 of group 1 metals, and of course also ammonium ion. Good. Now another important one is that all hydrogen trioxocarbonate 4 salts are soluble. All of them are soluble. So take note of that. Hydrogen trioxocarbonate 4 is different from trioxocarbonate 4. So the hydrogen trioxocarbonate 4 salts are acid salts, while these ones are normal salts. So the hydrogen trioxocarbonate 4 salts are soluble, while the trioxocarbonate 4 salts are insoluble except the group 1 trioxocarbonate 4 and ammonium ion. So given this clue now, what's the answer to this question? Which of the following salt is slightly soluble in water? When we say slightly soluble, we mean what? Sparingly what? Soluble. You can see silver chloride is completely insoluble. It's not sparingly, it's not slightly, it's not also what? Soluble. So it is insoluble. Then Na2CO3, of course, all sodium salts are what? Soluble. So that is not correct. Then lead 2 chloride is insoluble. As you can see from our matrix, it is insoluble. So, and the only one that possesses that slight solubility in water is calcium tetraoxosulfate 6, because it is sparingly what? Soluble. So the answer is option B. Question 9. Which of the following solution will have a pH less than 7? Which of the following solution will have a pH less than 7? Now, this question is on hydrolysis of what? Salt. you may need to watch our video on hydrolysis of salt to learn more about the hydrolysis of salt. We have added the link in the description. Now, what is hydrolysis of salt? Hydrolysis of salt is a phenomenon whereby when salts dissolve in water, they will react with the water to form either an acidic or alkaline solution. So when we say pH less than 7, that is what? Acidic solution. So examples of salts that will undergo hydrolysis are basically salts of weak acids and what? Strong bases, and salts of strong acids and weak bases. These are the salts that undergo hydrolysis, complete hydrolysis, right? Now, when these salts dissolve in water, the water will split them up into their constituent what? Acids or bases, or parent what? Base acids and what? Base. And depending on the strength of the acid and base, the hydroxide ion or the hydrogen ion will predominate in the what? Solution. So if it is a salt of a strong base and a weak acid, the hydroxide ion will be dominant in the solution than the hydrogen ions. Therefore, the solution will be what? Alkaline in nature. That's pH will be greater than 7. If it's the salt of a strong acid and a weak base, the hydrogen ions will be more dominant than the what? Hydroxide ion, right? And of course, which will make the solution to be what? Acidic, with a pH less than what? 7. So how do we know whether a salt is a product of a weak acid or a strong base? Now let's look at this. Na2SO4, sodium tetrasulfate 6, dissolves in water. What happens? The hydrogen ion will combine with the negative radical, right, to form the acid, that here H2SO4, while the hydroxide ion will combine with the metallic radical or the positive radical to form the base NaOH. Sodium hydroxide is a strong base and H2SO4 is a strong acid. So in this case, this salt will not hydrolyze because there will be equal amount of hydrogen ion and hydroxide ions in solution. So they will cancel themselves out, right? So the pH of this salt will be what? Neutral. pH will be 7. Likewise, sodium chloride. Sodium chloride plus water will give you what? NaOH plus HCl. Strong base, strong acid. pH is what? 7. Na2CO3. Na2CO3, sodium triazocarbonate 4 plus H2O. So the hydrogen ion will combine with the non-metallic radical, that's the anionic radical, and that will give us what? H2CO3, while the hydroxide ion combines with the metallic radical, that gives us NaOH. Strong base, weak acid. Strong base, weak acid. So what will be the pH? Strong base, weak acid. Which one will dominate? Hydroxide ion or hydrogen ion? Of course, hydroxide ion will dominate. So the pH will be what? Greater than what? 7, because it will be alkaline in nature. And lastly, ammonium chloride plus water will give us what? Hydrogen ion combines with the anionic radical, that is HCl, while the hydroxide ion combines with the metallic radical, that's NH4OH. Strong acid, weak base. Strong acid, weak base. Which one will dominate? Hydrogen ions or hydroxide ions? Of course, hydrogen ions. So your pH will be what? Less than 7. Because the solution will be what? Acidic. Now the trick here is how to identify a strong acid and a strong base, or weak acid and a weak base. Now strong acids, there are just 3 based on your syllabus: HCl, HNO3 and H2SO4. These are strong acids, right? Strong acids. Based on your syllabus, means that every other acid is what? A weak acid based on your syllabus. That's your H2SO3, H2SO3, H2CO3, H3PO4, CH3, all organic what? Acids. They are weak acids based on your syllabus. Okay, now strong bases. Strong base or strong alkali, you have NaOH, potassium hydroxide. You can add calcium hydroxide. So these are what? Strong bases. While others like ammonium hydroxide, all other hydroxides, magnesium hydroxide and co, are all what? Weak what? Bases. Copper 2 hydroxide aluminum hydroxide and weak bases. Then there's also one here. This although barium hydroxide is also a strong base, but it's not in your syllabus, so let's leave that. Okay, so these are weak acids, and these are weak what? Weak bases. So by the time you combine these two, weak acid, strong base, will give you what? pH greater than 7. Strong acid, weak base will give you pH less than what? 7. Strong acid, strong base give you pH equal to what? 7. Alright, so which of the following solutions will have pH less than? So that's acidic. So for my analysis, the answer will be what? Option D. So question 10, the last for this edition. Salts that contain water of crystallization are said to be what? We've already answered the question. Salts that contain water of crystallization are said to be hydrated. Yes, they are hydrated. They are not efflorescent. Efflorescent are substances that lose parts or all of their water of crystallization. We had explained that in our last video, right, or in our last tutorial. So they are not efflorescent, but they are what? Hydrated, right? They are not anhydrous. They are not deliquescent. And deliquescents are the ones that will absorb moisture from the air and dissolve in it. So the answer to this question is what? Hydrated. Salts that contain water of crystallization are said to be hydrated, which is option D. So that brings us to the end of our tutorial for today. If you were able to learn anything from this tutorial, like this video, drop your comments, and subscribe to this channel, especially if this is your first time here. Don't also forget to turn on your notification bell to know you get updated whenever we upload our new videos. Remember, the journey of 1,000 miles begins with a step. So endeavor to take that step and keep moving till I see you when I'll see you.